We're here at gotomath.com working some calculus problems, and we're down here in the section on optimization, and looks like we're going to be doing three here, and it looks like there's only one problem. What's up with that? All right, round to three decimal places. Okay, find the point on the graph that minimizes the distance to the point 410. um, Probably when you actually work this problem, we're going to end up having a graph down here, which I haven't programmed a graph in, but you'll see a graph and then you'll see this point right here. So anyway, find the point on the graph that minimizes the distance to the point 410, and then the graph, let's see, this y is equal to 6x plus 4. So we're minimizing distance, so that means that we're going to be probably using the distance formula, taking the derivative of it, and going from there. Okay. So anyway, let's write this down. Okay, let's move over to the whiteboard. We got a little bit of stuff here to work out. All right. So what are the two things they gave us? They gave us the point, which was 410, and then they gave us y is equal to y was equal to what? 6x plus 4, I believe. Okay. And so basically, I'm going to just kind of sketch something out right over here so you get an idea of what's going on. So if I were to actually graph this equation here, let's use a different color. How about we use green? All right, now I'm just going to kind of approximate this thing. So we got some line like this right here. All right, and then we have a point 410. We'll say that this is the point right here, 410. We'll say right here. And we're asking, so this is 4 right here, we'll say, to find the point on the graph. I think that this graph actually has a slope of 6, should be a whole lot steeper than what it is. But they're asking us to find the minimal distance between a point on the graph and this point here. In other words, if you looked at a point on the graph right here, this distance is obviously going to be greater than if I picked up, for example, this distance right here, this point on the graph. You see? Okay? So we're looking for that point on the graph that minimizes this distance, and obviously it's going to be somewhere in here. And I'm going to tell you that this graph should actually be a whole lot steeper than what it is. And actually, when you go to this problem, I'll have a graph and a point and so forth, so you'll actually see it. All right, I should have already programmed that in, but I didn't. Okay, so we're trying to minimize distance. We want to minimize the distance. In other words, we're going to need the distance formula, right? We're going to need the distance formula. So let me just write if you had forgotten the distance formula, I'm going to write it up here. We've got x of 2 minus x of 1 quantity squared plus y2 minus y1 quantity squared. Okay, so this is what we're trying to minimize. Now, we're going to let this number here be x of 1 and this number here be y of 1, and then we'll let this number here be y of 2, okay? And then of course this number here will be x of 2. Alright, so let's go ahead and plug this in. Now I'm going to go ahead and write this not in radical form, but I'm going to go ahead and write it in exponential form because we got to take the derivative of it. All right, so x of 2, which is just going to be our x, minus our x of 1 right here, which will be our 4, and this right here is going to be squared. All right, and then so we have y of 2. Now this here is going to be our y of 2, so that means it's 6x plus 4, okay, minus, this is our y of 1 right here, 10. Right, so the whole thing right here got replaced, or y got replaced with all of this, since it's equal. And then, of course, we're going to go ahead and write this exponential form. All right. So now, this is what we're going to be minimizing, and that means we're going to be taking the derivative of it. So I'm going to write d prime is equal to, okay. And actually, this needs to be simplified, really, before we do that. Let me just erase that. Okay, so I'm going to rewrite all of this. So we have x minus 4 squared plus, so we're going to have 6x minus, let's see, 4 minus 10 is 6, right? And that's all raised to the half power. Now let's go through, let's take the derivative now. So d prime is equal to, so I'm going to take the half, bring it out front, rewrite the whole thing, rewrite everything inside, x minus 4 quantity squared plus 6x minus 6 squared, and of course we subtract 1, so we have a negative a half. Now we have to take the derivative of everything inside the parentheses, and that means the derivative of this first. And I'm going to write a bracket over here, kind of separating this. So bring the 2 out front. X minus 4, and of course to the inside, bring it out, it's just 1. And then we have plus. Now we're taking the derivative of this piece here. So bring the 2 out front. Rewrite everything in parentheses. Minus 6, subtract 1 from the exponent, and then of course remember we take the derivative of what's inside, so the derivative of 6x is 6, and of course derivative of negative 6 is 0, so we don't have to write anything there. Okay, well, we just took the derivative, it wasn't too bad. Now what we're going to want to do now is go ahead, clean this thing up, and we're going to rewrite this again, clean everything up. Now we have a negative exponent here. I'm going to be taking that down into the denominator, and this stuff here is going to stay up in the numerator. Okay, now I'm going to explain this, so I don't have to rewrite this twice again. This a half right here is going to be multiplied by this and then by this, so it'll be distributed across. But what's a half times 2? 1, and then a half times this 2 here is also 1. Okay, now remember this is going down into the denominator, so just pretend it's not even there. So we're going to end up with x minus 4, so I'm going to try to skip some steps here. We got x minus 4, and then we're going to distribute this 6 across. Remember the 2's already been multiplied by the half there. So we end up with plus 36x, and then minus, is it minus 36? Yeah, of course it is. Minus 36. And then that's going to be all over. And you know what? I'm just going to go ahead and write this back into radical form. Okay, I'm going to write this back into radical form. X minus 4 squared plus 6x minus 6 squared. Alright, so we're going to want to, you know what, I'm just going to write it right over here. How's that? We'll clean this up. So we have x plus 36x is going to be 37x, and then negative 4 minus 36 is, what is that? That's, so my brain conked out on me, 40. Alright, and then of course it's all over the square root of 6x minus 4 quantity squared plus 6x minus 6 squared. Alright. Now, what's the next thing you do when we're looking for min and maxes? We take the derivative, right? And then we set the derivative equal to 0, and we look for those critical numbers. So we're going to set this thing equal to 0. 37x minus 40 over the square root of x minus 4 squared plus 6x minus 6 squared. Okay? Now, we take the numerator. We don't need to worry about the denominator. Okay? Take the numerator, set it equal to 0. Right? It's going to be the only time this thing's going to be equal to 0. And then solve for x. So basically, we're taking the numerator here, 37x minus 40, finding that critical number. So we got 40 over 37 is equal to x. 40 over 37 is equal to x. Now the question was, yeah, it says round to 3 decimal places. Around 3 decimal places. So I'm going to say approximately, I don't know, what is that? We know it's a little more than 1, isn't it? There, 40 divided by 37 is 1.081. I'm getting 1.081. So approximately 1.081. Of course, you want to take this number here now, plug that into y so we know what y is. I think it was asking for both numbers, wasn't it? And then y was, man, that is really sloppy, but I hope you've, I'm trying to write neat. Y was 6x plus 4. Okay. 6x plus 4. So 6 times 40 over 37. 6x plus 4. Right. Of course, we're going to say this is approximately times that by 6. Add 4 to it. I get 10.486. 10.48. 10.486. Okay, so we got both of our numbers. We got our x. I'll just rewrite it here. X is equal to 1.081, and actually these are approximate signs, and y is approximately 10.486. Now remember, to find the minimum, to be sure that it's a minimum, remember we do our number line, but I'm skipping that. You can work on that yourself, okay? And then put your critical number here, which happens to be this guy right here, 40 over 37, and then do a test point, make sure that this is a minimum, okay? But I mean, I'm going to tell you it is, but in the real world, when you work your own problems, right, and you're not sure that it's a minimum, then I already hit that, then that's what you want to do, obviously. Okay, so I believe those were the two numbers. X was approximately 1.081 and Y is approximately 10.486. 10.486. And of course you can see here I've got this how the setup should actually be, right? And of course Y is 6x plus 4 goes into here. Okay. All right. Sounds good. So come on over, practice that, try to get it, work that problem out in less than 3 minutes. Should be able to work that out in less than 3 minutes. All right. Even though it took me a long time, but I'm trying to explain it to you. So we're here at gotomath.com, and I shall see you there.